Hi, so we will discuss today the sequential circuits. So I have here comparison between the combinational circuit and the sequential circuit. In this, output depends only upon the present input. Speed is fast. It is designed easy. There is no feedback between the input and the output. This this is time independent. Elementary building blocks of logic gates, or in the building block of a combinational circuit, are logic gates used for arithmetic as well as Boolean operations. Combinational circuits don't have capability to store any state. As combinational circuits don't have clock, they don't require triggering. These circuits do not have any memory elements. It is easy to use and handle. Okay, so that the examples of the combinational circuits are encoder, decoders, multiplexers, and demultiplexers. Just like what I've said from the previous video. Now, we are going to discuss the sequential circuit. What is sequential circuit? So, in this, output depends upon the present as well the past inputs. Speed is low. It is designed tough as compared to a combinational circuit. There exists a feedback path between the input and the output. This is time dependent. Elementary building blocks are called flip-flops, mainly used for storing data. Sequential circuits have capability to store any state or to retain earlier state. Sequential circuits are clock dependent. They need triggering. These circuits have memory elements and it is not easy to use and handle. So the examples are the flip-flops and counters. What is the comparison between the block diagram is this one. So, sorry, malabo siya. So, we will go to the next one. We will discuss it later. As you can see, this one is the example of the combinational circuit. How many input and output, they are independent. They also called open loop. Walang loop na nangyayari. While in sequential, we have feedback, and that is memory element. Okay. So, for introductions, we all know handheld devices, cell phones, navigation receivers, personal computers, digital cameras, etc. na meron na tayo ngayon are processed information represented in a binary format. The technology enabling and supporting these devices is critically dependent on electronic components that can store information, and for example, they have memories. Sequential circuits, however, act as storage element and have memory. They can store, retain, and even retrieve information when needed at a later time. So this is the block diagram of a sequential circuit. As you can see, I'll pop here on the screen the picture of the combinational circuit. The main difference of them is this memory element, because this consists of combinational circuit to which storage elements are connected in the format of feedback path. The storage elements are devices capable of storing binary information. The binary information stored in these elements at any given time defines the state of the sequential circuit at that time. The sequential circuit receives binary information from external inputs that, together with the present state of the storage element, and determine the binary value of the output. So, the output will depend on the previous output and the present input. The above clock block diagram demonstrates that the output in a sequential circuit are a function not only of the input but also the present state of the storage element. The next state of the storage element is also a function of external inputs and the present state. Sequential circuit is specified by a time sequence input, outputs, and internal states. So there are two main types of sequential circuits, and they are classified as a function of timing of their signal course: asynchronous and synchronous. Synchronous sequential circuit is a system whose behavior can be defined from the knowledge of its signal at discrete instant of time. The behavior of a asynchronous sequential circuit depends upon the input signal at any instant of time and the order in which the input change. The storage element commonly used in a synchronous sequential circuit are time delay. The storage capability of a time delay device varies with the time it takes for the signal to propagate through the device. A synchronous sequential circuit may be regarded as a combinational circuit with feedback. Okay. So, asynchronous sequential circuit employs signals that affects the storage element at only discrete instant of time. Synchronous is achieved by timing device called a clock generator, which provide clock signal having the form of a periodic train of clock pulses. So when we say clock pulses, they are square waves. So that represents the clock signal. And as you can see, the difference between the synchronous and asynchronous sequential circuit is these pulses that are entered into the flip-flops or our memory element. The clock pulses determine when the computational activity will occur within the circuit. The signals, external input, and otherwise determine what changes will take place affecting the storage element and the outputs. Synchronous sequential circuits that use clock pulses to control the storage element are called clock sequential circuits. They are called synchronous circuits because the activity within the circuit and the resulting updating of stored values is synchronized to the occurrence of clock pulses. So, when it is said that it is synchronous, of course, it should be along with the time, at the same time. The same blink of the clock that should operate. The storage elements, memory used in the clock sequential circuits are called flip-flops. A flip-flop is a binary storage device capable of storing one bit of information. Okay, so all of the things that you can see in the logic, all the logic devices or most of the logic devices are IC, but inside the ICs have different components. Depends upon the function of it. Okay, so flip-flops are also gates, but combination of gates resulting to have a storage element. Okay, so we will discuss them further the lecture. Okay, the output are formed by a combinational logic functions of the input to the circuit or the values stored in the flip-flops are both. The values that is stored in a flip-flop when the clock pulses occur is also determined by the inputs to the circuit or to the value presently stored in the flip-flop. Okay, so before we go to latches, I will discuss to you the different types of shifters and counters. I think it should be discussed here in the sequential circuit, not on the previous video or the previous lesson of combinational circuit because shifters and counters also involve clock or timing so that it will function. Okay, so we have 5 types of counters or shifters. We have a buffer. Then we also have shift to the left, shift to the right, and ring. Mom, why 5? There are only 4. Of course, in ring method, we have 2 times, ring to the left and ring to the right. Okay, so I will show you the example of a buffer. Why is it called a buffer? Because when you say buffer, you're just pushing it out. Whatever you give, you are just going to pass it through. Or ipapasa mo lang kung anong in-input sa'yo. Just like this circuit. As you can see, why is it sequential? Because this involves clock. This is our clock. When I'll pop here the circuit of this clock that we usually use, and we are using the 555 timer IC. So like CSO or Computer System Organization, I am introducing the memory there as part of the computer. So you should have knowledge or idea of the timer, how to construct it based on the schematic diagram that is popped here. Okay, so yan yung kinukuha natin. The output is being fed or input here in the clock signal. Why is it buffer? Because what you input is just what you get. Now, as you can see, again, in slow motion, the output is waiting. Before lumabas yung output, as you can see, pag nag-clock siya, umilaw to, then that's the time na mag-iilaw yung output natin. So that is why we need clock. In any sequential, it depends, the output depends on the clock, the timing of the clock. Now, buffer meaning like this, if my input is 1, 1, 0, 0, then the output is 1, 1, 0, 0. Nothing more, nothing less. No movement. It will change when I turn off the switch. Now, these are switches, these are the inverters, and these are the outputs. Okay, that is the buffer. Now, I also have here shift to the left. Shift to the left meaning the output is being shifted to the left. The direction of the output is going to the left. Okay, so now it is shifted. Pero I will remove this one so that it will be, the previous one, this one is ring. Then this one, when we remove this, this is the shift to the left. Why shift to the left? Again, take note of the timing of the clock, this clock. When I shift it on, every time that the clock turn on, it will give signal to the IC. Okay? The outputs are synchronized with the clock. On, off, on, off. And the outputs are being shifted to the left. Now, this is ring. Why? I turned off. So as you can see, there are 2 high inputs. And it will just move around the circuit. So that is ring to the left. Shifting to the left, ring because the outputs and the input are in connected with each other. Bilog lang siya. Dire-diretso lang yung output niya, walang putol. So that is ring to the left. As you can see, the connection is we are using D flip-flop or the transparent flip-flop. And the inputs are the D and the output is the Q. Yun ang kinuha ko. Then all the clears are connected to an inverter, which leads to when I reset it, I just put it on and reset na siya. And the pre-state is always 1 when you're connecting it. Okay, so I also have here shifting to the right. So this one is the shift to the right. Why shift to the right? Magkamukha po sila. As we will see, we will check the flow of the lights. So the flow of the lights or the output, yun ang mag-determine if that is shift to the left and shift to the right. So this is shift to the right. As you can see, we also have a switch for reset. Sorry. So off siya. Pag na-on siya, then saka siya magpa-function. Okay, so I input 1. Again, the sequence depends upon the clock. The output, yung paglabas ng output niya magdedepende sa clock. Magsishift siya papunta sa clock, sa right. The same time na mag-on ang clock natin. See? Ito, pinatay ko siya. Pag binuhay ko, wala pang clock, hindi siya lalabas. But pag nag-clock na siya, saka siya lalabas. Sige. Pag nag-clock siya, saka lumalabas. Now, how do we make it ring? Yun, umabot ako. So, ring na siya ngayon. When I connected the last output on the right to this OR gate, it will make it ring. Kaya ako sa ginawang OR gate para mas madali na i-manipulate. Okay? So, once I put 1, see, nagbago siya. So, naging 2 ngayon. Reset natin para mas kita nyo. 1, 2. So, the lights now are, we have no output in between the two lights. So, yan ang shift to the right. At shift to the right and ring to the right. So, those are the 5 types of shifters. Shifters and counters. Let's go to storage element, latches. A storage element in a digital circuit can maintain a binary state indefinitely as long as the power is delivered to the circuit. Storage elements that operate with signal level rather than signal transitions are referred to as latches. Those controlled by a clock transition are flip-flops. Latches are said to be level-sensitive devices, while flip-flops are edge-sensitive devices. Although latches are useful for storing binary information for the design of the asynchronous sequential circuit, they are not practical for use as a storage element in synchronous sequential circuit. We have 2 types of latches, the SR latch with NOR gate and SR latch with NAND gate. What are the difference between the two? The differences are when you're going to use a NOR gate as latch, the reset input should be where the Q should be the output, while the set should be the Q bar. In NAND gate, set will output the Q and reset will output the Q bar. And the function of the latch will work on 0, 0. Ito. And the undefined will work on 1, 1. Mamamatay siya. Then, in this one, this part, this is the truth table for NAND gates. At 0, 0, it is open. Both are open. And in 1, 1, that is the latch. Then here, if the input SR is 0, 1, sa NOR, the output will be 0, 1. Pag 1, 0, 1, 0 din. Pagdating sa NAND, baliktad. Pag 0, 1 ang input na SR, the output is 1, 0. Pag 1, 0, the output is 0, 1. Okay. Simplify natin. Here, this is the example. For those who have experienced my CSO subject, nagawa na natin to doon. So, if the input, there are two columns, the NAND and the NOR latch. Here in the NAND latch, okay, when the input is 0, 0, in NAND, kapag 0, 0 siya, dapat 1, 1. Pag 1, 0, kailangan 0, 1. Pag 0, 1, 1, 0. Pag 1, 1, it should be the last state. So, ang last state ng fourth line natin is 1, 0. So, the output is 1, 0. Then, pag nag-0, 1 siya, back to 1, 0. Pag 1, 0, back to 0, 1. Pag 0, 0, mag-on ulit siya. While, in the NOR, 0, 0 should be the last state. As you can see dito sa table na to, 0, 0 is the last state. That's why I stated here, a last state of 1, 0. So, kapag nakita niya yung 0, 0, 1, 0, yung ilalagay niya. Then, pag 1, 0, 1, 0 ulit. Pag nag-0, 1, change to 0, 1. When it becomes 1, 1, magiging 0, 0 siya. Pag 0, 1, 0, 1 ulit, 1, 0, 1, 0 ulit. Pag 0, 0, 1, 0. I have here the simulation of the latches in Logically. So as you can see, the first part is the NAND and the second part is the NOR. Remember that NAND latch, if the input is SR, the gate na merong S na input should be the output of Q. Then the gate na merong R na input, the output should be Q bar. Baliktad siya, inverted siya when you go to this part which is the NOR latch. The NOR na merong R na input will have Q output. Then the gate that we have, the S input will be the Q output. Okay, so let's put we simulate the table that I've shown you before, that I simulated last time. This one, the last input is 1, 0. The last input of 1, 0, remember, XOR, itong NOR kasi ang kailangan na merong last state. So, first input of 0, 0, the output of NAND will be 1, 1. The output of NOR will be the last state of 1, 0. When we put 1, 0, the NAND will be 0, 1. Sorry, natingin ako dun sa 0, 1, then the NOR is remain 1, 0. When you change it to 0, 1, the NAND will become 1, 0, then the NOR will become 0, 1. When we put 1, 1, the NAND will remain the last state, which is 1, 0, and the NOR latch will turn off. Then next tayo 0, 1. 1, 0 siya. Then 0, 1 to. Then when we turn it to 1, 0, 0, 1 ang NAND, 1, 0 ang NOR. Then when we turn off, last state ang NAND, then remain on both ang NAND. Okay? So that is the simulation of the latches. Now, puntahan natin dun sa